Sorry. Alrighty. Once again, good afternoon, and thank you for joining me on this 5 o'clock session Tuesday. My name is Hector Linares. I'm a program manager with the Virtual Machine Manager team. I primarily focus on the standards-based storage management that we've done in the product, starting since VMM 2012 RTM. And so I will take you through the R2 feature set that has been built as part of the R2 wave of releases that you've been hearing about at TechEd. And, it's 5 o'clock. I want to leave this as open as possible. If you guys have any questions, anything you want to bring up, feel free to go to the mic. Otherwise, I'll have time at the end of the session. So I'll be talking about all R2, so I won't necessarily point out this is new, this is old. Everything I'll be talking about is essentially all the new storage management scenarios and features. I will be talking about storage area networks, network-attached storage, and fiber channel. So, ideally you have some familiarity with this, or at least if you haven't worked with it directly, you know the people in your organization that do. Some familiarity with PowerShell, because I will be doing some PowerShell scripts as part of this session. The first demo will be on fabric management and what we do with fiber channel switches and zoning. So, stick through me stick it through the demo if you can't. If you don't use fiber channel today, but definitely a big request from a lot of our customers around supporting virtual HBA and virtual SAN. And finally, I will be touching on the file server, scale-out file server deployment. So if you are familiar with bare metal provisioning in the VMM today, then that'll just build on top of that knowledge. How many of you have actually used VMM, bare metal provisioning, for Hyper-V clusters? 1, 2. So all the integration with baseboard management controllers, waking up the server, boot from VHD, et cetera. Okay. So in VMM 2012 RTM, we started with 3 pillars on how we do storage management. And so we focused on mainly insight into the environment, essentially solving the issue of what do I actually have deployed in my data center. And so that's our insight management, and we heavily leverage standards-based management for that. We then said, all right, let's make sure that we're flexible. In other words, when we do this, we can do this to ensure that it spans the enterprise. So starting with, we started with SAN on Fiber Channel, then SAN on iSCSI. In SP1, we added SAS support. Then we also added NAS support, so NetApp or EMC devices that implement SMB 3.0. We also had that support. And, we continue evolving that. We made sure that we gave you some flexibility on how you assign that storage, whether it's through classification, so you can, essentially express an SLA of storage as gold, silver, bronze, and then ensuring that we did all the assignment management. So in the LUN case, the unmasking, or in the share case, the ACLing. We ensured that there was extensive device support, and this is again through all the plug fests that we attend through SMIS and SNIA. We actually go 5 times a year to ensure that we have the best coverage across different devices. And we've also ensured that today we don't have a logo program, but we do go through a validation, and for validation, essentially a really long script that exercises all of the functionality, all of the scenarios that VMM that VMM automates, and we give those to our partners. And then we work with partners to ensure that they can pass tests, that their providers scale, the arrays scale to the VMM level, and so that's the partnership that we have with different partners. And finally, the automation. And so again, we have the insight, we know what's out there, we know that we have the ability to manage those devices, and then we've taken care of some common storage scenarios around provisioning storage and using the storage in a Hyper-V environment. So we are explicitly focused on virtualization management, and so everything we do from a storage perspective is in the context of virtualization. Now, since we do build on top of Windows Server 2012, if you want to manage that same storage, but maybe in a SQL context or Exchange context, or your line of business application, you can still leverage a lot of the same primitives that we take advantage of in the platform to do very similar workflows. So we build on what's called SMAPI, that's a WMIB2 provider, that supports WMI, and also PowerShell. And so some of the things we added with, now with R2 is this scale-out file server provisioning. Before we just managed scale-out file servers, now we can actually deploy them. So And we also do the now storage management not only for the physical machine, but also in cluster case. So if you have a cluster of machines, we will do the masking, unmasking, for example. And more importantly in this release, and I've got a few demos on this, we now can manage storage in the context of a virtual machine or a service tier. How many of you are familiar with VMM services, service templates, computer tiers? Okay, so VMM has an ability to to model an application, maybe a 3-tier application, into what's called a service template. We deploy those service templates, they become service instances. And now you can actually expose or unmask fiber channel storage to a service instance, primarily what's called a computer tier. So I'll show you that in the demo. And also now we're also the orchestration layer for disaster recovery. For those that have seen the keynote demo on how we're offering DR as part of, there's a Hyper-V recovery manager service sitting in Azure, and then you've got VMM in both, maybe primary, secondary site, and so we are the underlying engine that actually gives that service the ability to do failover, failback, planned and unplanned. So I'm not going to go through all of these boxes, but I just want to highlight that as part of the 2012 wave of products, so we're talking about Windows Server 2012 RTM and System Center 2012 SP1. There was a ton of features that were delivered. There's some gaps that we had in SP1, primarily around ODX support and virtual HBA support. So we're closing up the gaps. But more importantly, there's a lot of storage capabilities that were delivered, both from a platform perspective and on the management side. And this gets better now, and we were just covering this right before we started, now that System Center and Windows Server are not only organizationally aligned, our planning is aligned, our execution is aligned, and our release is now aligned. So when you guys get Server 2012 R2, you'll also get System Center 2012 R2. So there's a lot of focus that we had in the SP1 release on enterprise storage management, and now with R2, so in the platform, and in R2, we're catching up to some of these capabilities that were part of the underlying platform. So first, there was a lot of improvements that we've done on how to actually enumerate all these devices. And so if you have, for example, an HP 3-PAR array with a few thousand physical disks, it would take us a little bit of time to actually get all that information in. So we've done a lot of work on enumeration. Or if you have 30,000 LUNs on a VMAX, EMC VMAX, for example, it would take us a little bit of time to get that in there. So we've done a lot of work there on improving our enumeration. Any changes that happen in the environment, we'll get indications or essentially eventing from the underlying providers coming up into Windows Server and VMM. So that makes sure that we're continue to be scalable and continue to support any out-of-band changes in the infrastructure, make sure that we have the latest and greatest information. The introduction of virtual HBA support, that's now part of System Center, of VMM. And so we've done two major things here. First, we support Hyper-V and virtual HBAs. You can model VM with a virtual HBA inside of what we call a template, and you can take that template, deploy an instance of a VM or a service tier. You'll have VMs with a virtual HBA. You can then connect them to what's called a virtual SAN. So this is a Hyper-V construct. In Hyper-V, you can essentially take one or more physical fiber channel ports, group them into what's called a virtual SAN, and then that's the entity that's used to connect to a virtual HBA. So similar to a virtual NIC connects to a virtual switch, which then you have traffic going over physical ports. Very, very similar concept with virtual HBAs connecting to a virtual SAN, and then traffic going out over a physical fiber channel port. So we've taken this a step further and said, well, and this is obviously, with a lot of feedback we get from customers, it's great if you manage virtual HBAs. That's awesome. We need it, because we have a lot of fiber channel storage and we have a lot of tier 1 applications that need to be virtualized. Awesome. Problem is that with virtualization, I can deploy VMs really fast. And so, the on-demand nature of virtualization is great, but I need now to configure the fabric or fiber channel switches. And so that then adds all the friction back in of being able to deploy on demand. Okay, and so we've taken care of that by actually using standard space management again, and now giving you the ability to automate the provisioning of zones and activation of zone sets inside of using Virtual Machine Manager. And then finally, around deployment. So ODX was a very big feature from a SAN perspective that was released as part of Windows Server 2012. VMM did not have any of those optimizations. as part of VM deployment. We now have that as part of new VM from template. There's a lot of other workflows where we could have taken advantage of this, but given the time constraints and resource constraints, we've only optimized new VM from template to a CSV or a file share. Okay? And I have a demo of that. And we finally have integration with differencing disks. And so in this case, now you can deploy a new VM, and as part of that provisioning workflow, VMM will also create the diff disk. And so the difference here is that if you don't have a base disk on the, maybe the CSV or a file share, the VM can't be created because it's just a diff disk. So we also take care of deploying the base disk as well as part of the first VM deployment, making sure that that's stored on the CSV or file share, and then we'll hang a diff disk off of that. So the first one is going to take a little bit of time. Every VM after that will be fast. All right, so let's set up the first scenario. Again, we're talking about enterprise scenarios, and so in this case, I'm wingtip. So if you guys, if you attended Vijay Tiwari's session on kind of like R2 of VMM overview, he was talking about wingtip and Contoso. So here I'm the wingtip. I'm Aaron. I run my infrastructure. I've got a lot of SAN investments, and so I want to take all those, let's say, for example, SQL clusters that I typically would only be in a physical server. I want to bring those into virtualization. So with Server 2012, you can have many CPU, large amount of RAM. Now you can have fiber channel storage directly mapped into the VM. What was missing was obviously the VMM orchestration and VMM automation. So here's, I want to fully automate that provisioning of shared storage to my SQL guest cluster. Sorry. So typically SQL is part of a multi-tier application. So there's obviously the first requirement of, I need to model my application that has a database layer using virtualization. So that's the first problem statement as far as how do I actually do this in the context of SAN. I need to do this in a virtualized fashion. That means everything needs to sit within Hyper-V. And I want to make sure that whatever I do, I still get the agility of virtualization. And so, some of the requirements, I might have multiple volumes that go to this set of VMs. They could be 10 terabyte volumes. They could be large volumes. They could be optimized volumes. Anything that the SAN has, I want to make sure that I take advantage of those capabilities, but I want to do this in the context of a virtual machine. I got to make sure that these LUNs are shared across multiple virtual machines. So if you've done this before with a nice SCSI LUN, you have to enable the initiator. From the initiator, log on to the target, at the portal, log on to the target, and then do that for every virtual machine to get the shared case. So if you want to build out, for example, a failover cluster inside of the VMs, and so now you can do that with with virtual HBAs using fiber channel storage. And the last piece is support for live migration. So for those of you that have used our NPIV integration in previous releases, this is essentially a VM that sits on a fiber channel LUN with a vPort that you've manually created, manually zoned. And now that the LUN is exposed, that's where you store the VM. So if you wanted live migration in a cluster, not going to happen. Because essentially the cluster could migrate the VM workload, but the storage would, the vPorts wouldn't get deleted and created on each host. So we supported MPIV, but it wasn't scalable. It was not in the context of Hyper-V and a virtual HBA. So we've essentially, in SP1, we've deprecated support for MPIV, and in R2 now we've stopped supporting altogether the old way of doing MPIV provisioning. And now we're going to essentially streamline this all through Hyper-V and virtual HBAs. Okay? Now, when we did a survey on how many customers this would impact, we got around 5%, a little less than 5%, of customers using the old way that VMM does this. Does that affect anybody here? MPIV, old traditional way of deploying? Okay. So what does the solution look like? I've got a Hyper-V host. I've got one host here. Obviously, I would have multiple in the live migration case, but for the simplicity of the demo, of the setup, I've got a Hyper-V host. I've got two fabrics. So fabrics in the fiber channel context are essentially, think of them as a LAN, right? So these are a set of connected switches, fiber channel switches, that offer a fabric where different devices will eventually communicate with each other. Now, just plugging them in doesn't mean that they actually can talk to each other. And so where am I going to start? So I got my switches, and then I've got to create, now I've got physical fiber channel ports on each one of these on the host. I've got to first create my virtual SANs. Right, this essentially binds a virtual fiber port to a Hyper-V virtual SAN. When I deploy my VM, let's say it might have two virtual HBAs. I then need to attach the HBAs to the virtual SAN. So that just gets me the Hyper-V side. Actually, now I need to actually talk to the storage. So the way that I actually talk to storage, first I need to connect storage to the virtual machine. So that's when I create zones. In this particular case, in a production case, you deploy a dual redundant fabric, essentially two switches, and they don't need to cross-communicate. The idea is that you have two independent paths down to your storage array. So your storage array is typically highly available, two controllers, just a big meaty machine that is always highly available. You need two paths to storage. You can obviously do it, one path through a switch, but if the switch goes down or the fabric isn't available, you've lost connectivity. So you have dual redundant fabrics connected all the way up to the VM, which is why you need a virtual machine with two HBAs. So I got the Hyper-V side. My service template is where I model this, essentially a machine tier with two virtual HBAs. And then when I deploy my instance, I can have multiple VMs per tier. Okay, so in the demo that I'll be doing, I've got two virtual machines for the service instance. And then finally, once I've done all that work, I get my LUN, I expose it up to the VM. And in this case, I'm unmasking a LUN into the virtual machine directly. Hyper-V does not have to know about this LUN. That means I don't have to zone the physical HBA ports on Hyper-V and connect them to the array. So I'll be showing that as well. Let me switch over to the first demo. Hopefully this didn't get disconnected. Okay, good. So far, any questions on the setup for this first demo? Yes?
So the VM is not in a cluster per se, it's just a single workload, right? Single VM.
You could do that, or you could have two VMs that are attached to the same LUN. And in that case, you can create a failover cluster with shared storage. Right. Yes. Okay. Alrighty, so I will show you here first the fact that I've already got two service templates deployed, and these are the ones that I'm going to use once I want to expose storage. But I'm going to switch over to my demo here. All right, so what I'm going to do as part of this demo is actually do take a VM template and bring that into a service template and then deploy that. So I get a template. A VM template, again, is a property bag that says this is what my virtual machine looks like from a hardware perspective, from an operating system perspective, in other words, unattend.xml, and any other settings that I might want as part of a virtual machine. So I've got one that I want to apply to my computer tier template. So I get an instance of that. I'm going to create my service template. All right, so for the service template itself, I just essentially give it a name. And then I'm going to add a tier to that template. Again, a service template could be a web, line of business, database. So this will be a one-tier template just for the simplicity of the demo. And I'm going to use the VM template as a model for that computer tier template. Then this is a very generic template, so I didn't assign it to any networks or anything like that. So I'm going to basically tell the template right now, connect to DC Manager. That's my internal network, and that's how I want you to have connectivity to maybe other workloads or maybe external. And then I'm going to peek in to that service template by getting the configuration I'll get the configuration for the template. And then essentially every computer tier has a set of configurations. So I'm going to get my VM configs. Again, since I'm going to deploy a new service instance from this template, I've already specified in my template that I want two virtual machines as part of that tier. Again, this is to get the shared storage and failover clustering. So I'm going to tell it where to deploy each VM, so simple C:\VMs. Now, I'm going to hit enter there. So I've essentially got two HBAs per VM. Okay, so HBA11 and HBA12 is for the first virtual machine, and what I want to highlight here is that I'm connecting them to vSAN 02. So that's this here. Now that's going to be my storage classification. All right, so I'm going to talk more about, sorry, not storage classification, fabric classification. This is essentially a friendly name that you would give to your fabric. Fabrics typically come in as a worldwide port name, so we give them a nice name through classification. So you have vSAN 02, that's the classification that you want to assign. Again, remember, as part of deployment, you might not know the exact fabric or the exact virtual SAN you want to connect to. You want to abstract it and say, find me the host that's connected to this type of fabric. So vSAN 02. And here, I'm going to use the virtual disk configuration. It's essentially saying for every one of the OS disks, I want to use a differencing disk, and I'm going to use the base disk of 98407. I had a script before that I was using, so I'm reusing that. And then I go through update service configuration. Now, this is actually running placement. Right? This is actually finding out all my hosts and everything it's connected to, and it's going to tell me where I can deploy this service instance. So I'm going to show you, just as an example, if I were to do a get VM host ratings, this is essentially how VMM tells you for this host group. Maybe in this case is all hosts. Give me all of the hosts that can take in this VM configuration. Right? So if you see here, the VM configuration 0, that's the one I actually want to deploy. So give me all the hosts that are actually capable of handling this VM. Again, the complexity of the VM is needs CPU, needs memory, simple enough. 2 virtual HBAs connected to vSAN 02, which I showed you before. Of the 4 hosts that I have, it actually shows me only one has a non-zero star rating. So in other words, it has a star rating of, I forgot to put it in here, but it's like 4.6. All the other hosts essentially tells me that there's no virtual switch connection to this network I want, and there is no virtual fiber channel SAN with the required classification. So it's already ruling out all of the hosts that it can't go to. So far, so good. And then I'm not going to do it in this case, but I would then go and do a new service, and it's going to go off and deploy this thing. So let me clean up this demo. Okay. So with some hand waving, you see those, watch the cooking shows, they essentially pull out the made turkey and it's ready to go. So in this case, I have a service template that's already deployed, right? And ideally it would be connected to the right fabric. So I set up a little bit of a bad configuration just to show you some of the things that we've done from an integration perspective. So in this case, I've got a service here with a VM that's powered on, powered off. If I go to the properties of this VM inside of the service tier, the computer tier, I can go to storage, and then I can add my fiber channel array. So in this case, I'm onboarding the array to the VM. Okay? So I would pick my target ports, I would pick a bunch of initiator ports. That's all good, right? But if I go to the next VM, go to properties, I'll go down to storage, and I'll see that I actually can't add the next fiber channel array. So there's a reason for that. So let me switch over now to the physical host itself. So I'm going to right-click on N08 in my computer view, go to properties. I'll first show you that in the hardware tab, if you're familiar with this view, we show you physical NICs, right? And for example, the logical network that they're connected to, maybe the VM networks that are exposed through it. In a similar way, we will show you the physical fiber channel ports that are installed on this machine. And in this case, I've got 2 ports connected to my Broadcom production SAN, and the classification is prod. And I've got 2 ports connected to my Cisco SAN. So would you have the typical configuration? Probably not. Just it's my demo environment, so it was perfect to show you the difference. So we've brought the fiber channel fabric under management. That's how I'm able to get all this information as to what it's connected to. Otherwise, it would just be a normal port, and you would have no connectivity information. This is where vSAN 2 is connected to. That's all great. So what can I do with this information from a physical host perspective? In the same way that I can onboard an array to a VM, I can then go add fiber channel array to the physical host. Now, I don't have to do this. So again, to use virtual HBAs, this is not a requirement. But what I want to show you is that we've already done all the work of filtering out all the other arrays, all the other fabrics, and it's just showing you the only thing that this physical machine can actually connect to. So we're trying to avoid the case where you have a list of worldwide port names that you would manually type in, et cetera. We're actually just trying to simplify this and say, listen, we know based on discovery, again, the insight part, we know what array is available on this fabric. We know what fabric it's actually being presented through, so Broadcom fabric, for example. The reason why this isn't showing any others is because there is no other real network that for this array. There's no fabric for the other fabric for this array. So I would, if let's say I had my IBM array, which is also on the Cisco fabric, if I actually had discovered that, you'd actually see it in the list here. So we filtered the list, and we essentially give you the target ports and the initiator ports. So I know that this physical machine can connect to my HP3 port. So let me cancel out of this. Let me go back to this virtual machine, back into the hardware config. So I showed you before. I showed you before that the physical ports. I forgot to show you that you then take those ports and add them to what's called a virtual SAN. So the virtual SAN is where you connect the virtual HBA to. So in this case, the production, the Broadcom production SAN is actually what I want to be connected to. This is why we can't onboard the array. So I'm going to switch the virtual SAN for each of these VMs and hit OK. We don't have an apply button, so I actually have to wait for this to complete, and I'll go back into the properties. So I'll go back to the same properties for the same VM, and I'll click on storage. And now I can add my array. Sorry, let me slow down. So now I'll go to the add button, and now before I could not click on this, now I can. Because again, we've recognized that now we're connected to the right fiber channel virtual SAN that's on a set of fiber channel ports that can actually see, without a zone, can actually see the fiber channel array. So when I click on that fiber channel array, again, the 3 part shows up. Now in the context of the virtual machine, I can then pick my target port and then pick the set of virtual HBAs, sorry, the worldwide port names for the virtual HBA that I can connect to that I want to zone. So I'm not going to walk through the zoning piece, but essentially, once I hit OK there, we're going to go and touch the switch. We're going to, we'll touch the switch database. We'll create the zone. Then you would go and activate the zone set that actually essentially makes it happen on the fabric side. And what you would end up with is I'm going to go to a service, another computer tier. I will go to the go to the properties of the other virtual machine, storage. And once the zoning is complete and the activation is done, now I've got a virtual machine, an array onboarded to my virtual machines. So you would do that for each virtual machine. Now, you do have the option of adding a disk directly to the VM that would not be a shared disk. That's one option. The other option is if you go to the computer tier. So this is, again, the tier that has all the virtual machines. There could be 1, 2, 8, 20, if necessary. You go to Properties, Storage, Similar View. Here, this is where I would add a LUN. I can carve out a new LUN on the HP3 part, add it to the computer tier, and now it would be exposed to all of the virtual machines in that computer tier. So that's essentially what I've got here. I've already got a LUN unmasked to all the nodes or the virtual machines in this tier. So if I were to switch over to the cluster view, so this is on the physical side, right? You could have a tenant that wants the storage for maybe a database tier. So if I were to switch to Fiber Channel Cluster 01, this is essentially the cluster built out of VMs. Okay, so these are virtualized or a guest cluster. After it's been unmasked, I can go off maybe, well, all right, give me 1 second. Hopefully I can connect, okay. And what I wanted to show you that in Server Manager, you can see the virtual machines and all of the disks that it's aware of. Come on. Okay. So interesting. What do I do? Let me try something. So bear with me. Sorry about this. Let me try something a little different here. No, that's not going to work either. Wow. Give me 1 second here. Sorry about this. I'm going to try a TS gateway, and if that doesn't work, then we'll just move on. What is going on? So far, 3 demos from the same environment. So far, so good. So I really apologize for this. All right, let's give this a little bit of time to think, and we'll move on. And then if it does come back, we will we'll continue. Yes, sir.
I noticed that you showed the target as one worldwide name and initiators, 4 separate. So I guess 2 of those were on each fabric. Is that correct?
So the question is that when I was going to do the zoning, I showed 1 target port and then multiple worldwide port names for the initiator side. So essentially, the way that it's configured in my lab, we have 1 port on the 3-par on that fabric. That's why you only saw 1. Typically, you'd see 2 or 4 for multipathing. So that's 1. On the initiator side, every virtual HBA needs 2 worldwide port names. And 2 per virtual HBA. So the reason for that is that when the VM gets instantiated by Hyper-V, one of the V ports actually gets created. So Hyper-V integrates with MPIV. It creates the V port using through the virtual SAN on the physical port, right? And that's the one that actually logs into the fabric. Okay.
One virtual HBA per fabric.
Yes, and then the other one would be on the second fabric. And the reason for the second worldwide port name is on live migration. As part of live migration, Hyper-V will create a planned VM, use the other V port, the other worldwide port name, to create the other V port, make sure that the paths are fine and everything's good, and then it'll actually hydrate the VM and get it over to the other side. So in order to get 0 interruption and live migration, that's why you need to zone 2 worldwide port names per virtual HBA, and then 1 virtual HBA per fabric. Yep. So this is struggling to connect. Let's move on for now. So the way that we enable this is, again, through standards-based management. The key highlight of this slide is that we use the storage management API that's part of Windows Server 2012. Now, we use SMAPI today for all of the, let's see, hopefully this doesn't crap out. Okay, we use SMAPI for all of the storage management from the array side. Right, so any kind of SAN or spaces, if there's a provider that's an SMP provider, which is another option as far as managing SAN arrays, that's all done through SMAPI. Another smaller component of SMAPI is SIM pass-through, the ability to use SIM methods, SIM classes to talk to providers directly. And this is today, at least, how we do all of the NAS management and now fiber channel management. All of that is available. So let's say if you wanted to create your own automation, and it was maybe not in the context of virtualization, you can use SIM pass-through to create zones, activate zones, etc. At the end of this slide deck, I do have the script for that. If you guys, if that's interesting to you, the script is there. So this essentially breaks down all of the different types of devices that VMM can manage and the different provider models that exist that as far as exist in the industry, whether it's a proxy provider or an embedded provider. Typically, embedded providers sit on the controller itself. Proxies sit through another machine on the network. And in the scale-out file server case, we use a unified cluster-aware spaces provider that sits on the scale-out file server itself. So it's a proxy, it's an embedded provider. So I talked about classification, and so there's before R2 we had one type of classification called storage classification. This essentially allowed you to tag a pool with gold, silver, bronze. And the feedback that we got from customers is that this is great, but we want a little bit more flexibility. What if we didn't have a SAN, right, to begin with, or maybe the SAN didn't have any kind of provider? The request is give us the ability to maybe assign classification at a higher level, at the host level. And so now we've introduced the ability to classify volumes. So even if you don't have a SAN, maybe you're using complete JBOD, totally disattached, maybe not even an HA cluster environment, you can still go into VMM and change the classification per volume and label it gold, silver, bronze, etc. We've done the work as well to string that up all the way into cloud deployment. So if you have a tenant or a self-service user using a cloud, and you want the customer wants, or if maybe from the IaaS perspective, if you want to give them gold storage as part of their gold cloud, they can now deploy VMs to gold storage. Now, that's great if you have volumes, right? That's what we talked about so far. We've also introduced the ability to assign classification at the share level. And so in this case, I have silver on my pool, right? And pool goes all the way up, and that everything gets inherited up. So if you do nothing else, just classify the pool, and you're good to go. But if, let's say, you turned on encryption for a file share, or maybe it's using a parity space instead of a mirror space, you can now classify the share differently, and now you can land VMs on silver or gold storage as part of self-service. We've taken a very similar approach and said, well, how about you classify your fabrics as well? And so in this release, now you can classify your fiber channel fabrics as gold, silver, production, test dev, etc. We do this at a one-to-one mapping today. And where we want to go with this eventually is to say, I want to have my gold fabric, my gold classification. And then when we fully automate the provisioning of zones, today it's not fully automated, just automatable through VMM. Once we fully automate it, we'll go off and say, on your gold fabric, even if it's a dual redundant fabric, we're going to go off and create the zones. So those are now the four types of classification. Pool classification, volume classification, again, in the case where you don't have a SAN. Share classification, if you want the flexibility of saying this share is different from another share, and also fabric classification. The list of partners that we've been working with so far, this is the SP1 list, and this is what I presented at MMS. We're working on the R2 list, but this is essentially, there's 2 pages, the partners and their status so far for SP1, and in the next coming months, we'll work with them on the R2 wave of release. If there's a set of partners, storage partners that are not on this list, let me know. And 2 things. I will talk to them, and also it'd be great if you guys can talk to them as well and tell them, hey, we want to participate and make sure that it's all supported through VMM. So far, just to recap, I've talked about standards-based management for managing the underlying arrays, whether they're fiber channel, iSCSI, or fiber channel or SAS, and managing fiber channel switches. If you have a SAS switch, it's essentially for us, we don't have any advanced management, but that would be the interconnect. So we talked about fiber channel storage. It's not always the case that you need fiber channel storage inside of a virtual machine, but you need virtual machines. And maybe you want to deploy them really fast. All right. Typically, how you would do this before is either you would circumvent VMM altogether and just deploy them yourself. You would maybe land the VHD on a CSV or a file share and then create diffs off of that manually, and then go to VMM and create your VMs using existing diffs. Otherwise, you would wait for bits to deploy the VM. So in a multi-terabyte VHD deployment, for those that have actually sat through a bits deployment, and I'm pretty sure that's everybody using VMM, that can take a long time. right? That can take 20 minutes depending on the type of network. Background Intelligence Transfer Service, or BITS, is a great technology that we've been leveraging since the beginning of VMM. And that essentially allows us to create a trusted connection between two machines that is completely AD independent, right? So you can have a library in your protected enterprise environment network going all the way out to the DMZ environment, and we would use bits to transfer that VHD. So that all is great, except that it adds a bunch of traffic on the network, it adds a bunch of traffic on CPU, and if you don't need to worry about DMZ cases, maybe you just have a VDI environment where you just need to deploy many VMs. That typically wasn't something you could do through Virtual Machine Manager, even if you automated it. So in a typical VDI environment, first of all, you want to make sure that it's efficient from the beginning, right? So when you deploy the first payload, the first base VHD, can you make that efficient? You'd like to, right, as much as possible. Every VM that gets spun off of that virtual base VHD, if you're using diffs, again, you want them to be space efficient. If the SAN supports deduplication, you can turn on deduplication at the SAN level. You can use VMM to track any kind of over-provisioning that you might have done in your environment. At the end, as an appendix to this slide deck, I've got a bunch of scripts on how you can do that as well. Track over-provisioning at the pool level, so thin provision LUNs, and also thin provisioning at the VHD level, right? And there's really no alerting for that today, so you can definitely create a script that allows you to see all the VHDs that are thinly provisioned deployed on a volume that could also be thin provision on a LUN, so you can see the cascading effect. So one solution is to use ODX. So offloaded data transfer, how many of you have actually... It's trying to talk to me. I don't know what it's trying to say. It's just beeping. Give me 1 second. Let's see if... Don't know. Anyways. Okay, so offloaded data transfer. How many of you have actually used this technology in your environment? If you have a SAN, maybe... Okay. So offloaded data transfer, again, a technology in Windows Server 2012, essentially allows you to offload the entire deployment of the virtual disk, of the VHD, to the SAN itself. So you don't use any network, you use no CPU in the environment, it's all done by the SAN itself. So one way to do this is to use ODX with the CSV and say, I want to take my VM template, standard VM template with a VHD. Now the requirement is obviously that the source and target have to be on the same array. That I know of today, there's no partners that actually span arrays. Totally possible with the technology itself, but today it's within an array. So your library share has to be in the array, or your LUN, and your destination has to be on the same array itself. Typically, these ODX transfers are space efficient, so you don't even have to use a diff, as an example. Some partners, like the NetApp array that I have here, is essentially deduped already from the beginning because it essentially uses remapping of blocks, right? So if it doesn't have to write the block, it won't, right? And then it only essentially tracks any new changes. So we've optimized this for the VM deployment path. New VM from template going to a CSV or a file share. We don't have any other migration or any other path optimized. Hyper-V, on the other hand, if you initiate a live storage migration, that's already off ODX. It leverages ODX. And finally, once the VMs are on the destination, again, these are full VHDs. They might be efficient on the SAN, but if you want, you can then also enable deduplication on the volume, which is another technology in Windows Server 2012. Again, this is in the context of VDI. I want to make sure that that's perfectly clear. In Windows Server 2012 R2, you can now enable deduplication in the scenarios of VDI. Okay? So like I mentioned before, a bits deployment essentially consumes CPU and network from the library because it essentially needs to read some chunk of data. It transfers it over HTTP or HTTPS, and then on the Hyper-V set, then it has to write that chunk of data. So that repeats until the VHD is done deploying, even if it's on the same SAN. It could be a Windows Scale file server or a NetApp SAN in this case. Bits isn't smart. Let's assume ODX isn't enabled, just for whatever reason. Maybe it's a different array. We will still do some reading if you do an offloaded copy, since we're using copy file 2 APIs, and there's a new deployment option called use Windows copy. So in this case, we will do only one read and one write, to essentially transfer the data over. Where the magic really happens is with ODX. So an ODX, essentially, the transfer happens under the covers. It's proprietary to the array itself, but from a workload perspective, VMM doesn't care as long as the file gets to the other side or it gets to the destination. So my demo is back up. Let me switch over. So let me do the ODX demo, and then I'll finish up the fiber channel demo. Let's see. Let me set that up. Come on. It's not fair. Not fair at all. Either the network doesn't like me or the demo gods are not being fair to me today. I heard PowerPoint actually crashed on him. That was interesting. I heard about that in the speaker room. Again, I don't know what's going on. And I connected to TS Gateway, so I wasn't using any DirectX. All right, let me continue. Basically, the magic that would have happened is that I would have shown you a bits deployment of an 8 gig file. It would, I think it's when I transfer over, because the minute that I went back here. All right, let's see how long this lasts for. Okay. Very weird. Okay, so I don't know while this thing is thinking. Basically, I would have done a bits deployment. 3% after 30 seconds would have gotten you, I don't know, a few hundred meg maybe. And then I switch over to an ODX deployment. Essentially, around the same time, I can deploy the full VHD, configure the virtual machine, power it on, and then you would essentially see in the VM Connect screen come up, and then customization starting. Right? Essentially, in the same time that I would have deployed at 3% of the file, I can get the full VM up and running. Alrighty. Another option is to use the isolated target as an example. And so in the isolated target case, and this is the Microsoft isolated target, that's something that we started supporting in the previous release, and we shipped an SMIS provider as part of VMM CD layout. Now that provider is part of Windows Server 2012 R2. So now when you enable the Microsoft isolated target role, you essentially get an embedded SMIS provider as part of that. You can then point VMM to that provider and say, let me manage you. And in the case that you might have an isolated target that's clustered, that's supported, and now the isolated target supports VHDX, native VHDX, so that you get 64 terabyte LUNs, you get thin provisioning, you get a lot of cool things. Now, what can you do with that? So let's say you set up what's called a SAN copy capable template that essentially tells VMM, hey, I know that I sit on VMM figures out that the VHD sits on a LUN that's on an array that supports snapshot or cloning and/or cloning. Okay, that tells VMM, hey, I can use the provider and then snapshot this LUN many times. So that's a SAN copy capable VHD. You add that to a template, you make the template SAN copy capable. Now, you can still use the same template for any other type of deployment. Maybe it's ODX, maybe it's bits deployment. The template itself looks the same, but VMM knows that it can do another thing, which is snapshot or clone the LUN. So I'm not going to use that technology, the full automation of that, but I am going to say then, through VMM PowerShell, you can then create a snapshot of that LUN. You can unmask the LUN to your cluster or hosts, and then now you've got essentially a LUN with a VHD that is a sysprep VHD, hasn't gone through mini setup. And then I can hang diffs off of that. So either VMM can transfer the payload, the base VHD payload for you, or you can leverage the underlying array's capabilities on snapshot and clone to essentially get the payload over to the host. And so again, all the options are available through VMM. If you're okay with a clone, then essentially you would take up that additional space on the isolated target because essentially it's a full copy. If you want snapshot, then you can do a snapshot, which is an efficient provisioning of the LUN itself. So I talked about the isolated target itself. The key highlights again: native VHDX support, supports online resize, shrink, and expand, and support for clustered isolated targets. So I would show you the demo, but I'm afraid of this box. Every time I try to move over to it, it doesn't like me. Let's see. Okay. Let's see if this one goes. I'll try it one more time, and then we'll be done. Okay, never mind. I tried. Okay, so to summarize where we are so far, we talked about fiber channel arrays. We talked about fiber channel switches. We've now added iSCSI support. So if you have an array that supports iSCSI, that's fully supported through VMM. And in that case, you're provisioning through an Ethernet environment. From a storage perspective, we don't do any kind of VLANing or anything special from a switch perspective. Something that we'll work on. If you were part of the networking sessions, you'll see that we have some top-of-the-rack switch integration. So slowly we're getting there, but today there's no end-to-end automation for Ethernet switches in the context of storage. So fiber channel, iSCSI, SAS, fully supported through VMM. So let's talk about R2 and the new wave of capabilities in R2. And essentially here we're looking at, we started from the enterprise with high-end tier 1 scale SAN. We moved on to iSCSI. iSCSI Target in the Microsoft perspective gives you more of a software target that you can deploy on spaces if you want. But where we see a lot of service providers and going is that they essentially need commodity, cost-effective storage, but that still is scalable and capable of handling multi-tenant environments. And so you've seen Windows Server scale, right? How many virtual processors, how many virtual machines, the size of the clusters. And what you've seen as part of this TechEd wave of releases is now all of the scale-out file server capabilities and the SMB improvements. So SMB 3.02 is the R2 official version, essentially SMB 3.0. So you've seen all the capabilities in SMB 3.0. And so where VMM comes in from a management perspective is to say, well, take all of that commodity storage and you put it in behind 4 physical servers, and you install Windows, and you install the SMB file server. That's how you get SMB 3.0. And then so now you've got a highly scalable, highly resilient target. In this case, it's an SMB target, and all leveraging underlying JBODs, SAS disks that are cost-effective and commodity. So that's essentially the vision that we're going after from a cloud OS perspective. We've essentially got disaggregated compute and storage. So in the same case where a SAN essentially is independent of the compute, you have these scale-out file servers that are independent of compute. So you can scale each as you need. So if you need more storage, you can always scale that independently of your Hyper-V clusters. We're using industry standard technologies and devices, and using standard space management to make sure we can continue managing all these different layers. So VMM walks in, and I'm going to spend a little bit of time here since I don't have the demo. Is essentially first we say, all right, in SP1 you can bring a file server under management, but you had to go and create the file server yourself. We had 0 spaces integration. So we were compatible with file servers and Hyper-V clusters that had spaces provisioned, but we did no work to actually create the pools and then create the space. So first thing we do as part of the R2 wave, we first said, you got to get the servers out there. And VMM already has the technology and the capabilities to say, I want to take physical servers and put a role on them. So we already do Hyper-V role. So you can create a set of Hyper-V nodes, cluster them using failover clustering, assign storage to them, and then deploy highly available virtual machines to that Hyper-V cluster. We've taken the same primitives and said, let's now build out a scale-out file server. So we use a computer profile, right? What we used to call a VM host profile, and say, we want this computer to look this way. This is the NIC configuration. This is the local disk configuration. We want this VHD, and you're going to set up boot from VHD using that VHD in the library. So we can stand up these machines. We use IPMI and Smash to talk to the DRACs and the ILOs that are on the physical machine, because that's guaranteed to be on. The physical server might not be on, but the DRACs, the BMCs are definitely going to be available and on the network. So we talk to those BMCs, and we now can power on the machine. When you PXE boot the machine, that's when it gets the initial WinPE payload. So WinPE is going to be the first configuration, is going to do the first initial configuration of the physical server, and that's going to download the VHD. We'll change the boot config and make sure that it can boot from VHD. Now that the server's up, it's already got an unattend.xml file. It's going to go through customization. So mini setup will finish up. It'll be joined to the domain. It'll have the product keys. If you had a particular IP address for each one of the physical ports, all of that will be configured. Great. So now you've got a scale-out file server cluster up and running. So we've done the work of clustering the nodes, installing the failover cluster feature, installing the file server role, clustering the nodes, and then we go off and enable or create the scale-out file server role inside of clustering. So you have to do it twice. You enable the role from the add features and add roles perspective for every machine, and then you add the role to the cluster. That's your scale-out file server. So we've done all of that work to stand up that scale-out file server. We then take the unified spaces provider, now that it's cluster aware, and then we add that to VMM. So now the spaces clustered environment is manageable by VMM. So we see that as one entity. Previous to R2, if you wanted to manage spaces, you would connect to every physical machine, and you essentially had to construct the cluster view yourself. And so we've said no, that's not the right way of doing it, and so we use a unified provider to give us a view of the cluster from a spaces perspective. And that's what we use to then do all the intent-based management. So now that we've got the physical disk discovered, we go create a pool. So you can take 3, 20, 240 disks, bring them into a spaces pool, and we'll automatically make sure that it's clustered. That's part of the provider itself. It'll cluster the pool itself. And then finally, we use, yes? I think today the number is 4. Typical number is 4 that we see, 4 nodes. You can do more. Okay, so you need SAS, and you need to make sure that all the nodes in a cluster, in order to create a pool, right? So if you have 4 nodes, if you want to create a pool that can fail over across those nodes, you need SAS connectivity. In that case, it does need to be shared. Right, but you don't need is a fiber channel or iSCSI LUNs. These are essentially physical disks connected through SAS up to the. Yes, right, and so you would see 4 nodes, and then if you want to add maybe another 4 nodes to the cluster, you would add that. In this case, the shared storage is only to those 4 nodes, but you can make that part of an 8-node cluster. So 4 nodes to these JBots, 4 nodes to another set of JBots. Those 8 nodes don't all need to talk to the JBot. From a cluster perspective, you're going to see a pool, a space, and a CSV. And then you can layer on top a share. So from the workload perspective, it's a file share. The fact that you have independent SAS configurations in a cluster, that's totally abstracted. So then we get to the final piece, which is the intent-based management on file shares. And so now we've done the orchestration as well of when you create a file share, all you have to tell us is what pool, what size, and whether it's NTFS or REFS. And then VMM, along with the unified provider, will go off and create the space on the pool, make sure that it's a clustered space. We'll initialize, partition, format the volume, and then we'll present that to the cluster, make it a CSV, and once it's a CSV, we'll talk to the scale-out file server role and say, create me a share on that CSV. Right, so the end result of that is that then you can take that share and then ACL it to the cluster. So if you have a 64-node cluster, let's say, a Hyper-V cluster, you can essentially tell VMM, go off and create or add all of the computer accounts for every node in the cluster to that share. That's the ACLing piece. And then you can deploy your workloads onto that share. So I walked through the setup, but essentially, you want to make sure that you want low cost storage. You want from a private cloud perspective, you might not have, fiber channel arrays or iSCSI LUNs, and really now I'm taking the Contoso point of view and saying, hey, I want something that's cost effective, and I don't already have investments in, expensive SANs, and so, I want to make sure that I can use commodity storage, and more importantly, I might not have the expertise around maybe fiber channel provisioning, et cetera. So I want to make sure that I can use a converged network, and this is where we get into InfiniBand, RDMA, et cetera, as technologies on the infrastructure side of essentially creating a low latency, high throughput network for your infrastructure. So I want to take advantage of that. I want to make sure that I still have resilient storage, both on the physical side with the disks and also on the nodes themselves. So I want to have a failover type of environment. Obviously, SMB 3.0 gives you multi-channel, gives you the resilient file handles, and gives you the incredible throughput. So you've got a lot of the capabilities at the target level to make sure that you can be resilient and scalable at all the way to the very top. So the buildup that I would have, in a demo, essentially would be, you have a scale-out file server, nodes, attached to your shared storage. And this could be a tiered storage. You could have a set of SSDs and a set of SAS. There's a great talk on the actual, performance improvements in R2 around spaces with tiering and write-back cache. Right, so I create it, from my physical disks, I create a pool. That pool, and you create a space. You can have multiple spaces per pool. A physical disk can only participate in one pool. Once you have the pool, you can have many spaces, so maybe a parity space, a mirror space, a two-way mirror, three-way mirror, single parity, dual parity, all of that is supported. So you would have one or more spaces per pool, and then you would have a CSV per space, okay? And then a scale-out file server per CSV. You could have multiple. Through VMM, you can say, here's a share on CSV1, I have another share on CSV1. That's totally possible and supported by the platform, but typical path is you have a one-to-one relationship between your shares and your CSV. And then when VMM goes off and deploys those VMs, all of the VHDs would then land on that file share. So any questions on that? Okay. So from a hosted perspective, I do want to respect the boundary between the tenants and my infrastructure. But customers are still going to need the ability, they still need the ability to deploy maybe a failover cluster. Maybe it's a SQL cluster they need to deploy. How do you get shared storage up to those virtual machines if you don't have iSCSI or Fiber Channel? Now, one option is that you can virtualize the iSCSI target. Okay, you can virtualize the iSCSI target, put it into a guest cluster, which could be sitting on spaces, right? And then expose that target to the virtual machine, to the set of virtual machines. That's one option. Fiber Channel obviously isn't an option. You can't necessarily virtualize that. But the other capability is what's being delivered in R2, which is shared VHDX. And so in a shared VHDX case, I can essentially meet all the requirements of support for persistent reservations, which you absolutely need in a file server cluster. So you need persistent reservations. You want to deploy with minimal friction, right? So you want to give the customer the full capabilities of deploying a failover cluster, but you might not want to be in the middle of having to deploy the LUNs, et cetera. So all of that is now handled by VMM and fully automated through VMM in service templates. You can land these shared VHDXs on either a CSV or a file share. So that's supported on both sides. And all of this can be modeled inside of a service template. So in the same setup I had before, where I have SAS disks, my scale-out file server, I got my pool, I got my space and my CSV and a file share. Now I can, before I was landing individual VHDs per VM. In this case, I've got an OS VHD per VM. Obviously, that can't be shared. And then I've got one shared disk for both VMs. The two VMs do not have to be on the same physical machine. They can be on separate machines, right? And so you have scalability or high availability at the file server, scale-out file server level. You have high availability at the Hyper-V level. And now for the guests themselves, you have high availability as well. It's a lot faster without the demos. So again, I really apologize for that. All right, so we talked about fiber channel storage, fiber channel switches, all the provisioning that you can automate through VMM. The support for SAS, I didn't show that, but if you have a SAS array, that's also supported through VMM and standards-based management. If you have an iSCSI array, that's also manageable through VMM. And now, from a file server perspective, I didn't show NAS, but if you have an SMB 3.0 capable NetApp or EMC, that's manageable and supported through VMM using SMIS. And now with scale-out file server, we do support spaces and a full end-to-end provisioning. Now, the one that we don't do is if you have a Hyper-V cluster with spaces underneath. So in other words, a bunch of shared SAS directly attached to Hyper-V cluster, that's the one we don't automate. Right? We had to pick one, and this is the one that we decided to fully optimize, considering, again, going back to the vision and where we're going with the Cloud OS. And so, essentially completes the picture as far as the pieces that VMM can manage and where VMM has visibility into. The great components are the ones that, from a storage perspective, we don't do anything special with. If you go to the networking talks, we can obviously talk to top-of-rack switches in the context of remediation for networking connectivity, not so much for storage. So in closing, so the main customer pain points that we went after, as far as we wanted to make sure that we address problems where customers were spending a lot of time waiting for storage to be provisioned. Again, the greatness of virtualization is that you get on-demand provisioning. Storage, on the other hand, was a problem as far as it added friction to the overall deployment. We had a lot of customers telling us that the expertise level wasn't there. Maybe it was a different group in the enterprise, or maybe it was just a smaller company that didn't have all of the knowledge around storage and how to either automate storage or just normal storage operations. We also had larger customers that had many different arrays, and each one of them had a different API. So they wanted to do automation, but they couldn't cover everything, right? Typically, what they went after is human error. So they wanted to remove as much human error as possible, but you would automate some of the typical operations. So that's where VMM walks in and says, all right, let's work with the industry partners and throw in all of these capabilities to the product to make sure that we can do this in the context of virtualization. Partners as well started to see this value and said, hey, you know what? I've got consoles that need to understand maybe fiber channel switches in the context of virtualization. Can I use all of the knowledge that you've built up in VMM, pull that into my consoles, so now when somebody calls in and says, hey, I've got this host that's down or this virtual machine that's down, somebody that manages a fiber channel environment can say, okay, let me find your VM, again, in the context of VMM, and then find out maybe a switch is down, maybe a port's bad, maybe a cable went crazy, right? So all that can now be done from a external console perspective using the capabilities of VMM. And again, from standards-based management, a lot of partners are seeing requests for REST APIs, PowerShell, WMI, CLI, a bunch of different ways of how can we automate your device. And so again, in partnership with all our partners, we've said let's use standards-based management, and then using SMAPI, you have WMI and PowerShell built into the platform. And you can use that as a way of automating across many devices or maybe for a single device. And where partners can leverage this is that they can create extensions on top of VMM to then maybe do all the standard stuff. And if there's a special set of capabilities, you can use or partners can use pass-through to get to that functionality that may be specific to that device. And that capability again is for partners and also available to all customers. So the perspective that we're looking at is that with all the work that we've done in partnership with the partners that I showed before, from a customer perspective, that customers that are embracing the cloud, they love the fact that the automation piece, right? So we're simplifying and automating everything that's common in a cloud environment, whether it's tier 1 storage or if it's commodity storage. At the end of the day, it's fully automatable through VMM. From partners building solutions on top of System Center and Windows Server, again, this is hardware and software working better together, right? So if you're a device manufacturer, you see a lot of the workflows that now just work out of the box, more of a plug-and-play type of feel. And if you're maybe an ISV, you can build a lot of really interesting solutions using what VMM and partners have built together. And service providers, hosters, a lot of these hosters actually build a very similar stack, management stack, and platform to what is now offered in the R2 wave. And so we see a lot of them actually saying, listen, we already do this today. I actually see a lot more value in what System Center and Windows Server offers. So just to wrap up where we've been and where we are today. In the first 4 releases of VMM, we had very straightforward, very simplistic storage management. We essentially use VDS hardware providers for masking and unmasking, simple discovery. We integrated with NPI VWMI providers for vport creation, deletion, and we did some simple initiator log on, log off. In the 2012 release, we switched over to SMIS. So this is RTM. We switched over to SMIS, and that's when we started layering all of the fiber channel and iSCSI capabilities as far as what we can do in an environment. So in 2012 SP1, that's the first time that we shipped support for Windows Server 2012. Then we switched over to SM API. So again, still standards-based management, but we did the forklift effort of now using this new API. So we transitioned over all of the same capabilities, and then we added some more. Dynamic iSCSI target support, so the EqualLogic arrays or the Microsoft as the target, that's supported. We added support for SAS arrays, and then all of the file server as well. So NAS devices, scale-out file servers, file share creation, and ACLing. So that's up to SP1. So as part of the R2 wave, we continue to support roll-in all of those capabilities, and then we've added support for fiber channel, virtual SANs, virtual HBAs, fabric management, so that's all in green. We've extended the support for scale-out file servers to use file share classification, intent-based file share provisioning, spaces creation, spaces management, pool creation, and physical disk discovery. And to finalize that stack, we support ODX, VHD resize, and fully integrated VHDX support. And it works. I'm sorry I couldn't show you the demos, but all of that is definitely working in the release of VMM that you'll be seeing in a few weeks. So first, definitely thank you to all our partners that are working with us, and the list continues to grow. At the end of this, I do have my email and my Twitter, so make sure to tell me if there's any partners that you would like to see VMM work with. And a big thank you from all of us, of the product team to you, as far as customers using the product today. Thank you for your feedback. Thank you for all your support. And thank you for coming out to TechEd. And I appreciate it, and hope you like the presentation. And I'll take questions now. Yes? So yeah, the question is, for ODX, do we need hardware support? And so the answer, I was trying to bring up the more resources. There we go. So the answer is yes. The actual device does have to support ODX, and it's essentially a tokenized copy or transfer of data. And so there's a T10 spec that was released that Windows worked on with the industry, and so the array has to support the ODX primitives. So you probably need a firmware update as part of the array. Yep. So EMC today does support it through VNX and VMAX. And there's actually a video online through, I think that's on Vimeo, and they're showing 30 gigabytes per second using ODX. So yes, they do have support for that. Great. Any other questions? Anything else? Yes? Okay, sorry, can you come to the mic? Yeah, thanks. So the question is on information on deduplication on CSV. What kind of information would you like? Okay. Uh-huh. Okay. So the question is on the keynote and all of the new capabilities in R2 around deduplication support. So the first thing I'll say is that deduplication is now supported in R2 for live running VMs in the context of VDI. Technically speaking, it works in other cases, but the one that's actually being tested and optimized today is VDI. And one of the advantages of the VDI case is that you're pretty much guaranteed that all the VMs are going to look the same for the most part, right? So in that case, the way that deduplication works, it actually, when it creates the dedupe store, it essentially chunks out, similar looking blocks, right? And so once the chunking is done and it's got the dedupe cache, when you start booting up all these VMs, there's no need to read the data again from the disk if you already have it in cache. And that's what lands you the improved boot performance on similar VMs, because we're essentially reading from the cache. And this is not SSD or anything like that. This is just a cache that exists on the volume itself. And so that's how you get the faster boot times. NTFS dedupe. So the deduplication capabilities in Windows Server works with NTFS or REFS. And so that dedupe store sits on the volume. So yeah, and so it's supported for CSV, and I will show you the demo, but basically in a Scala file server, as an example, you can format it as NTFS or REFS. Yep. Sorry, what was the question again? I don't know the answer to that. If there was some limitation in the 2012 RTM timeframe, I don't know if now it's fully supported. If you can reach out to me, I'll get an answer for you. Great. Any other? Yes. Don't leave. For those that are asking questions, I got some dictionaries for you from SNIA. So please come up when you're done. When we're done. Yes.
Cluster share volumes for fiber channel arrays, is there a recommendation on the number of those you should map your volumes to? I've seen so many shared nothing clusters and shared everything clusters. I'm just wondering, what's the consensus? I mean, currently we have a VMware shop and we do separate clusters. We don't have one giant cluster.
Mm-hmm.
They're like, 6 to 8 hosts per cluster, and then those 6 to 8 hosts all share the same 2 terabyte line.
Right. So the question is around any recommendation or best practices on CSVs and how many physical servers they can be unmasked to. So it typically depends on the array itself. For example, on if
The supported array, one of the ones you
yeah.
you're checked out with, so we're supported now. That's the best.
Right. So any one of those arrays typically can support a LUN going to 64 nodes. But what we've seen, at least from customer feedback, is that if you have, once you actually put load on a cluster, at least for some arrays, a sweet spot would be anywhere between 10 to 16 is the right number to have. And you might run out of persistent reservations. Typically, a SAN is shared across many servers, right? Even if it's not the same cluster. You want to keep it in the 16. 16 is pretty much the number. Some arrays might scale differently, and it depends. So VMAX, for example, can support thousands of devices.
Guys in our team thought we should go with a shared nothing approach. Clearly, since we're 16 gig fiber channel, why would we do that?
It'd be interesting to see why they would say a shared nothing if you already have the fiber channel shared environment.
I think it was some of the learning curve around the clustering share. So I don't think it's that complicated. I think it should be.
Yeah, but then I do see some customers doing that. They don't need HA at all. They don't need clustering at all. They've got some ephemeral workloads that if the server goes down, it may be VDI, for example. Through the broker, they'll just get another instance, and things will get reconstituted at login time. So there it makes sense. You don't need all the extra layers. But typically, HA production, you want scalability, you want reliability at all the levels, and so that's the typical configuration we see. unless it's, like I said, ephemeral VDI test dev workloads. Yes?
I didn't say much about trim in here. Is that an SLIS function?
No, trim. So the question is on actually, I don't know your name, sir. Excuse me. I've got. So the question is on trim command. So trim and unmap is supported in Windows Server 2012. Thanks so much for everything. Take care. Sounds good. So that allows now Windows Server can be very efficient when it comes to reclaiming storage on the underlying array. So that's actually in the data path, right? So in the SCSI path, when you delete a file, NTFS will send out an unmap command, right? And then the data underneath will get, trim command, the data underneath will get unmapped. And so that is not a function of management, that's more in the data path.
So that would apply more to direct attached storage than a storage array?
No, it's typically the other way around. It applies more to a storage array than to direct attached storage. So you don't need a provider though to light that up. And the coolest part is if let's say you delete a file inside of a VHD, the VHD parser picks up the trim command and sends it all the way down to the physical device, right? So the VHDs will resize as well as the LUNs. Any other questions? Yes.
In our case, our fiber channel SAN is we have all data.
Okay. There you go. Thank you.
Would a solution where you put it's escaping me, solid state
Okay.
on the SAS array and do tiering with the SAS and the backend SATA, would that work?
So, and this is SAS on the physical server, or SAS already in the JBOD?
On a JBOD.
Okay. So I guess the question is, if you have SSD disks and SAS in a JBOD, can you do tiering?
Right.
Yes. So the answer is yes. With Windows Server 2012 R2, you can essentially create a pool and have two tiers: an SSD tier and a rotating media tier. And then when essentially that, depending on the policy you pick, you can have a LUN that maps or that spans both, right? And so Windows from a block perspective has a heat tracker, and in 1 megabyte chunks, it'll actually move things around and say these are the chunks of data that's being used the most. So this is subfile, not an entire file, but subfile. It'll move those 1 meg chunks into the SSD. All the cold data will stay on the rotating media.
Does it continue to keep some of that cold data or keep that hot data on the cold side, or does it just completely?
You could, so you can pin files. So now with some file system integration, you can say keep this file on that tier. So even if it is hot, it won't move things to the SSD side. So you can do that as well. Say again. There you go. So I think the optimizer runs every 6 hours. So it's not a real time moving of data. Now, when you pin, that's on demand. When you pin a file, it'll shove things around as soon as you say pin. Otherwise, it'll just run on a 6 hour scrubber. Say again. So the questions are, let me repeat this. The first question is on the how often does the tiering policy run? And the second question is on deduplication. How often does that run? I don't know the answer of I think it's every 2 hours, but don't quote me on that. It's not in real time either. So the data will land, and then the dedupe engine will run and start deduping the information.
And if I have 4 cluster storage systems, who actually, who does the duplication?
So the question is on a multi-node cluster, which node is actually doing the deduplication? The tiering is different, so I'll cover the deduplication. Deduplication is most likely done by the owner node, but I don't know that for a fact. But most likely it's going to be the owner node of the LUN. Okay, and especially in spaces, because essentially only one node can actually do raw I/O. Right? In the tiering case, that I don't know for sure. It's most likely the owner node, right? Because essentially it's got to move blocks around. It's got to do interesting things to the actual physical disks. and where you get the raw I/O is on the owner node of the space. So for tiering, for deduplication, it's on the volume. So that sits on the volume. If you were to move that volume somewhere else, that's totally there. If all the nodes were to go down, the store is already on the volume. For the tiering case, I think the heat map tracker sits on the volume as well. So if you were to take out that JBOD and put it into another machine, not that you typically would, but if you did that, all of that information is kept on the storage itself. Great. So for the gentleman in the back, yes. There you go. Yes.
So the rapid provisioning does not use ODX, like the SAN swapping part. Who are those two workflows different?
So the question is on offloaded data transfer and how does BMM integrate the various rapid provisioning scenarios. So in the ODX case, you have the source LUN and the destination LUN, or the source file share and the destination file share, have to sit on the same array. Okay. So in the case that, let's say it's a LUN exposed to the library, and what we'll do is say, okay, dual Windows copy, and then we'll just switch over to the Windows copy file 2 APIs, and then it'll take care of requesting the token, the array, and then writing the token on the destination, and then the data will just move at the array level. Okay. If it's a file share, similar. The token gets passed down, and then the data gets transferred. In the SAN copy case, there we're taking a full LUN snapshot or clone. And now when you present the LUN on the destination, maybe it's a host or cluster, it can't be a CSV. It's one LUN per VM. ODX case, you can do one VHD into a CSV. So customers are asking for both. They really wanted the one VHD into an existing CSV, and then you can have hundreds of VMs from that CSV. Other customers want the rapid provisioning, and they want the isolation. So that's where you get both. Great. So I appreciate you hanging out with me. And again, apologize for the demos. And I hope you have a great conference. Thank you.